Hello everyone. Today we're going to be learning how to balance an equation in an acidic medium. This is a very important process when it comes to um, doing anything electrochemistry. This involves redox equations, and it's important for AP chemistry as well as general chemistry too in college. So without further ado, let's get started. So the first thing we want to do is we want to find the charges of each element to figure out what is being reduced and what is being oxidized. So for this, we have nitrogen dioxide. Um, Anytime we have any sort of equation, rule of thumb, H's are +1 and oxygens are generally -2. If you have hydrogen peroxide, oxygen will be -1, but we will not be dealing with that right now. So we have nitrogen dioxide first, right? So this will be -2, but because there is two of them, there will be -4 total, which means nitrogen has to be +4. All right? Anytime you see an element by itself, it will automatically be 0. Very simple. Now we have this really big compound ion. But don't worry, because of our rules, we'll be able to solve this very quickly. So now we have the hydrogens, which will be +2 because it's +1 respectively, right, to make +2. And then we have oxygen, which will be -8 because you have -2 times 4. Now arsenic, right, to make that minus charge, you need to add a +5 to this because 7 minus 8 is -1, which is what the charge is. So that's arsenic. And then now you have nitrogen monoxide. So that's going to be +2 and then -2. Very simple because oxygen is there. Yeah. So now that we have all these species oxidized and we have all the oxidation numbers, now we can get started with the actual thing. So let's do the redox equations. So we're going to have the reduction and the oxidation equation under here. So let's start off with the reduction. The reduction is occurring in nitrogen. So we start off with n plus 4, and we end off with n plus 2. So reduction means gaining of electrons. So that means that this species is gaining electrons. My method when doing these is I like to isolate the specific thing that is being oxidized and reduced, and it will help exponentially for later in the problem. Next, we'll continue with oxidation. So now we have arsenic. So arsenic is a solid, and it is becoming As plus 5. Now to balance out the charges, you need to add 5 electrons. Excellent. So now that we have the half redox equations, what we want to do now is we want to sorry, we want to find the The next thing that you want to do is you want to have an equal amount of electrons being gained and lost, right? And so because of that, what we need to do is we need to multiply these equations by some number that will give us equal amounts of electrons. So the easiest number will be 5 and 2. All right, so now let's add 5 and 2 to these. So it will be 5n plus 4 plus 2As, right? The electrons cancel out, so we don't need to add the electrons. Yields 5n plus 2 plus 2As plus 5. Excellent. So now this is a checking step, right? So we can check this step to see if we're doing this problem right. So one thing that's very good is we can check the charges. That's a very good way of checking it. So on the left, we have a plus 20 charge, and on the right, we have a plus 10 charge, which means it's a plus 20. So that's good. And we have the same number of elements and atoms. We have 5 nitrogens and 2 arsenics on both sides. That means that this means we're doing this problem well. Excellent. So now what we need to do is we need to now that we have the balanced half redox equation, now we need to add those coefficients to the original problem. So now let's add them. So we have 5NO2. This is all going to make sense as we continue with this problem, and you'll see why, and it makes things so much easier. So now we have 2 in front of this ion, and then we have 5 in front of NO. All right, so that's what we have to do next. And after this, we have to figure out which side has less oxygens. All right, so in this, we see that the left side has 10 oxygens, and we see that the right side has 2 times 4 is 8, 5 plus 5 is 13. Excellent. So now what you want to do is you want to add water to the side that has less oxygens, because water basically is equivalent to adding oxygen to this equation. So we're going to have to add 3 waters, right? Because 3 waters has 3 oxygens, allowing this to be 13 total oxygens. Excellent. So now, because of this, now we have to add protons to balance out the hydrogens. So because the water brought in 6 H pluses, we have to take that into account. So on the right side, we actually already have 4 H pluses in this part of the thing. So now we have to add 2 more H pluses because of that. So now the final reaction will be this: 3H2O plus 5NO2 plus 2AS yields 2H2AsO4 minus plus 5NO plus 2H plus. Excellent. You can check it on your own, check the charges, check everything. It should be all good. It should be all good in the hood. All right. Now we're going to balance this equation in a basic medium. So really, the same steps apply for the first thing. We want to first find the oxidation numbers. So let's do that. So permanganate, this will be plus 7 because this has to be negative 8. And then this will have to be, so this is negative 6. So this has to be plus 3. And then you have plus 3 for the individual nitrogen ion. And then for this is very simple. This is plus 2 because it says it there. And then this one will be plus 5 because this has to be minus 6. All right, so now let's speed things along. This is the same stuff as we did last time. We have redox. So let's do the reduction first. So the reduction would be manganese plus 7 plus 5 electrons yields manganese plus 2. And then for this one, now we have to take into account that this is, what's it called? This has 2 of them, so we can just do this, 2 nitrogens with plus 3 yields, it has to be 2 nitrogens too, so let's just already add the 2 plus 5. And so because of that, now we have to do, there's plus 6 on this side, and there's plus 10 on this side. So now you have to do plus 4 electrons to balance out the charges. Awesome. So now what you want to do is you want to multiply both sides by something that allows the electrons transfer to be the same. So I would do 4 and 5. And so now the balanced redox equation will be as follows. 4Mn plus 7 plus 10n plus 3 yields 4Mn plus 2 plus 10n plus 5. Yes, all the electrons get canceled out, and this is our balanced redox equation. We can check this by seeing that the left side has 58 as a positive charge, and this side also has 58 as a positive charge, and they all have the same number of atoms and whatnot. Awesome. So now we have to add those coefficients to the balanced basic, the full equation. So it would be 4MnO4 minus plus, because there was already two nitrogens, we want to make sure we don't screw that up and put a 5 behind that. Excellent. Now we're going to yield that, and it's going to be 4Mn plus 2 plus 10NO3 minus. Excellent. Okay, so now we're almost done. Now we have to do what we did last time. Everything's the same as acidic medium. So now we have to add, we have to find actually the side with the least amount of oxygens, okay? So we have 16 oxygens in this molecule, and we have 15 in this molecule. So that means there's 31 oxygens in here. Now, for the other side, we only have 30 oxygens. So that means that we need to add one water molecule over here. Excellent. So now, after that, we need to add protons. So let me just move this over so we have room. We need to add protons just like the acidic medium. Nothing complicated. So let's see. Now we have to add plus 2. We have to add 2H plus to the left side. Excellent. And then after that, now we have the balanced acidic medium. And finally, we need to add just OH minuses that correspond with this proton that these protons that we added. So we're going to add 2 OH minus on the left and 2 OH minus on the right. And what happens when we have 2 OH minus on the side and 2 H plus is that they become 2 H2O. And why that's very significant is because there's 2 H2O on the reactant side and H2O on the product side, you want to cancel out this H2O and make this a 1 to simplify it. So now the last part of this equation will be just writing out everything. So 4 manganese per 4 MnO4 negative plus 5 N2O3 yields 4 Mn plus 2 plus 10 NO3 minus plus 2 OH minus. And that is how you balance in a basic medium. So just to recap, everything is pretty much the same thing, except in an acidic medium, you stop at the proton step, and in the basic medium, you have to add corresponding 2 OH. You have to add corresponding OH minus to the 2H plus. Awesome. If you have any other questions, comments, concerns, please leave them down below. Please like and subscribe, and I hope you all have a good day.